Well, good morning, everyone, and I'm here to talk to you about a subject that I'm passionate about and that I was involved with for over 20 years of my life, and that is space. And the idea that I'm bringing to you today is that we should go to space in part to look back at our own planet Earth. Why do people want to go in space? I'm often asked that question. A lot of people think, well, we want to go into space because we want to look out into our solar system, into our universe, to learn more about where we come from and what is our place in this universe. We are on a planet called Earth, which has its own moon, we call it Moon, and part of a solar system which has a star, which we call Sun, and we are one of millions of solar systems in our galaxy called the Milky Way, and there are millions of galaxies. So it's a fair question to want to go into space to learn more about where we fit in the grand scheme of things. But one of the things that I found out when I went into space was that it was also a good thing to go to space to look back at planet Earth, particularly at a time when we are putting a lot of stress on this planet that we call Earth, the home, the cradle of humanity. So that's really the idea that I want to talk about today. I will talk very briefly about what it's like to go into space as an astronaut because I had the privilege of doing it on 3 occasions. First back in 1984, and then 2 other times in 96 and the year 2000. In all cases, I flew on the space shuttle. When you're an astronaut, you train in Houston, Texas, at NASA headquarters, the Johnson Space Center. And apart from your basic training, you then do about a year of mission-specific training before you have your first flight. And that is basically the pattern that I followed. And 3 days before your flight, you go to the Kennedy Space Center, because that's where the shuttle is located, and that's where you're going to fly from. And some of you may have had the opportunity to see a shuttle flight from Florida. So when you go there, you go to crew quarters, and your training is over, and you're now turning your mind towards this extraordinary experience that you are going to live, that very few other human beings have had the opportunity to experience. And you spend time with your family, and you spend time basically turning your mind now towards the actual flight that is ahead of you, because the training is over. And then the night before, you go to bed and you hope that you're going to be able to sleep properly. It's a big day the next day, and it's a combination of, I remember feeling a little bit like a little boy the night before Christmas, excited at what was going to happen the next day. Also a little bit of trepidation. I was hoping that I would be able to get a good night's sleep and fall asleep so that I'd be well rested for the next day, and I did. I tossed and turned for about an hour, and then I fell asleep. And they woke me up at 3 in the morning. We had a breakfast. We had a last medical check. Then you put on your space flight suit. You can see on the screen there, you can see on the right at the bottom this kind of spacesuit that you wore before Challenger. But after Challenger, we went to the orange suits. And then you all go downstairs and get on a bus called the Astro Van, and you go out to the launch pad. And when you arrive out there, you go up an elevator to about 185 feet. The shuttle is vertical, of course, and you get on board. They strap you in, and they wish you good luck, and they close the door, and you're still 2.5 hours prior to liftoff. And it is the longest 2.5 hours in your life, because there's not a lot you can do except think about what lies ahead. And people often ask, are you nervous as an astronaut? And I would say that's probably the time when you have the butterflies, because you know that this vehicle, this incredible machine, is going to light up shortly, and that you are going to go into space. And fortunately, the time goes by fairly quickly as the ground control is checking everything, and you finally reach the point where you're ready to take off. And if the weather's good and the systems are working, then at about T-minus 6 seconds, they light up the first engine, T-minus 4 seconds the second, T-minus 2 seconds the third engine, and if they all light up properly, Then at T equals 0, the two big solid rocket boosters will light up, and you're on your way into space, and there is no turning back, and it's too late to change your mind. And you're going to go from 0 velocity to what's called orbital velocity. That's 28,000 kilometers an hour. So that's equivalent to about 8 kilometers per second. To give you an idea, I could be back in Montreal in 2 minutes if I was on the shuttle at this point. So that's how fast you're going, and that's how fast you need to be going in order to stay up there in orbit. And it's only going to take you 8.5 minutes to get to orbit. And you're going to experience a lot of noise, a lot of vibration, and some acceleration as you build up your speed on your way to orbit. And that 8.5 minutes is the best roller coaster ride you have ever been on. But you're really focused on obviously making sure that everything goes right. Your mind is not on enjoying the ride. Your mind is on checking all of the systems on board to make sure that everything is working properly and that you're going to make it to orbit safely. When you get to orbit, this is the kind of view that you experience. This happens to be over the Middle East. You can see the Sinai Peninsula. If you're good at geography, you'll recognize the Mediterranean. We're over the Red Sea. You can see the Dead Sea if you follow the Gulf of Aqaba upwards, northwards. And so and you can see the curvature of the Earth. This is at about 300 kilometers altitude, and that's where the shuttle flies at. And the space station's a little bit higher, but not much higher. And this is the kind of view that you get. And when you get out of your seat at 8.5 minutes, when they've cut the engines and you are in space and it's quiet and you realize you're floating, and you float over to the window and look out at the extraordinary view that is below you, you are consciously aware that you are experiencing something that very few human beings have ever experienced. I was the 150th human being to go into space. And when I looked out the window, I was speechless. I really couldn't take it all in. It was such a breathtaking experience, and it was in a way incomprehensible. And fortunately, I had the chance to spend time in space on my 3 missions, and a lot of my thinking about space has happened since that first flight. Now, we live on planet Earth, and there are 7 billion of us on this planet. Maybe as Canadians, we're not quite as aware of this because we live on the second largest country on Earth. But the population of this planet is probably going to reach 9 billion by the middle of this century. And we all share this planet called Earth. It's going to put a strain on this planet. An example is water. Water is already a serious issue for many countries on this planet. We know that the climate is changing. We're all aware of that. We know that food is not available to every country in the world and that there are still people starving today. And we know that water, an essential commodity for life, is scarce in certain parts of this planet. And when climate change occurs, it's going to change the conditions that exist in certain countries. It may even lead to tension within countries and between countries. But like it or not, all of us live on this planet called Earth, and we have to find a way to make sure that we take care of this planet. That is the central message that I want to pass on to you today. That is what has burned into my brain from the 3 flights that I've been on, because I've seen the atmosphere and how thin it is, and yet it allows us to live down here because it supplies us with the oxygen that we need to breathe. And we know we're changing that atmosphere. And I've seen the oceans. They cover 70% of this planet. And those oceans are not any country's oceans. They're shared by all of us. And so the realization that we live on this planet, but that we have global challenges, is really the central message, I think, that I want to convey to you today, and how we must use space to look back at our planet to make sure that we're taking care of it. This is a picture taken from space over Lake Erie. Now, the yellow tinge there may be attractive from a color perspective, but it's not a good thing. This is smog over Lake Erie. Some of this is from coal-fired generating stations in the Midwest, but the weather patterns bring it over to Canada. And we're responsible for passing our bad stuff on to other countries as well. That is something that you see with the naked eye when you're up there in space. And it's not just over the Great Lakes, it's over California, it's over the Mediterranean, it's over China. This is deforestation. When I first flew in 1984, there was 1 million square miles of smoke from burning of the rainforest in Brazil. For good intentions. This was to help clear some land for farming, but you couldn't even see the ground. Before 1984, this would have been totally green, but you can see the kind of deforestation that is occurring in one of the great lungs, of course, of this planet in terms of being able to absorb carbon dioxide. This is the Mangoki River in Madagascar, and you can see it. It looks like it's bleeding into the ocean. And the reason that it is doing this is because the area along the river has been heavily deforested. For good reason, in the sense that people need the wood. This is not a wealthy country. They weren't doing it just to be vandals. They were doing it because they needed that wood. But the result, of course, is that it caused soil erosion. The good land washed into the river and out into the Indian Ocean, as you can see it here. This is the Viedma glacier in Argentina, and I just chose this one. There are many others. But in the lifetime that I've flown, over a 16-year period, glaciers have retreated on this planet because of warming. They're like the canary in the coal mine. They're one of the most sensitive indicators of climatic change. And this is something that you can see, again, from looking out the window on board the space shuttle. Well, we need to go beyond just astronauts looking out the window and observing changes that are occurring on our planet. We need to also focus on using instruments to look back at our planet Earth. And I'm very glad that Canada, and you can see this is the RadarSat satellites, synthetic aperture radar that Canada built, has been flying since 1995. We now have RadarSat 2, and we're going to build successors to it. They allow us to image our country, the second largest country on Earth. They see through clouds, these satellites, and they see at nighttime. So they're better than a camera sensor because they can see the ground and the ocean at all times. That's the kind of sensor that allows us to monitor the health of our planet, of our boreal forest, of our agricultural lands, of our north where ice is moving and where ice is disappearing. This is the kind of Earth observation that Canada needs to do and other countries need to do, and that can be provided by this special vantage point of space. We are at the moment designing a constellation of RadarSat satellites so that instead of just having one going around the Earth, it takes 90 minutes to orbit, we'll have 3 spaced apart. So we'll have a higher frequency of rotation of these spacecraft over our planet, and therefore be able to measure things that happen in more quickly down on the surface of the Earth. This is a satellite that the Americans launched many years ago, and there's a Canadian experiment on it called MOPIT, Measurement of Pollution in the Troposphere. This is another example of very useful Earth observation that can be done from space if you put the right instruments up there. Because we have the technology today to very carefully see what is happening down on the surface of the Earth. And if we build the right sensor, we can look at some very, very specific details down on Earth. If we're monitoring, for example, crops, if we're monitoring crops in certain places, we can optimize a sensor up in space to look at that particular crop on the surface of the Earth because of the specific wavelengths that we're looking at with that particular sensor. So that's another example. Another example is CloudSat, weather, probably the most complex phenomenon in terms of complexity and continuously changing, of course, is something that we still have a long ways to go to fully understand. Well, we can put some very powerful instruments in space and look down on the surface of the Earth with these. This is CloudSat. It has a Canadian bit of hardware on board, a very crucial one. It's called a Klystron, and it helps us to look at clouds and learn much more about clouds, and this is all part of our understanding of what is actually happening down on the surface of the Earth. So this is the kind of instrument that we need to be focusing on developing. More advanced are what we call hyperspectral sensors. And these are sensors that really do take the electromagnetic spectrum, a part of it, and look at very defined slices of that spectrum, and in that way are able to look at very specific details of what is happening down on the surface of the Earth. So I think that, to summarize it, if we look at the last 10, 15 years, we've become more conscious of the fact that even though we are blessed here in Canada, that planet Earth is finite in terms of its ability to support some of the things that we do on it. It is changing continuously. We need to take care of it, and one of the ways that we need to take care of it is by understanding exactly what is happening on its surface, whether it's on the oceans or on the land. So my message to you is developing the technology so that we can look at it very carefully and look at very specific things, I think is one of the best ways that the government of Canada and other governments can allocate funds so that we can really watch the progression, because we definitely, once we have the information, then need to act on it, and that is where you get into the political will to do what is necessary. But in order to do the right things, we all have to agree amongst ourselves that we understand what is actually happening. So again, just to conclude, our planet is changing. It's changing dramatically. We become aware of it because of science and because of research. We need to continue that research. We need to understand more in depth what is actually happening to our planet. And so my idea to you today is, let's use space, yes, to look out into the universe and to try to understand it, but let's also look down at our planet because it's changing, and we want to make sure we keep it in good shape for generations to come. Thank you very much. Thank you. Thank you.